Hey, this is Miss Park. Today's video is on trigonometry in 3 dimensions. So I'll just remind you about trigonometry in 2 dimensions. There's our CN tower, right? We've had a question like this before where I ask you the height of the CN tower. And the reason I'm asking you that is because it's very difficult to measure this height, right? I would have to get a really long tape measure and climb the CN tower to the top to get that height. Right? And so whenever there's something that's difficult to measure, we usually find that if we can find measurement along the ground, so let's say, for example, stand at a particular distance from the CN tower and look up at the top of the CN tower with a particular angle of elevation, right? Then I can use trigonometry to calculate the height of the CN tower. And the angle of elevation can be found using a number of different tools that engineers and land surveyors use. So it is very possible to stand on the ground and look up and measure your angle of elevation. And finding distances along the ground is also easy compared to finding distances that are harder to find. So that's an application of trigonometry. In the case of the 3D, so this is 2 dimensions, right? I am drawing my diagram in 2 dimensions. In the case of the 3D, what happens is the thing that we're trying to find, we can't really reach. So there is often some kind of barrier. So let's say there's a river or something on the other side. So I can't get there. So what we do is we find information on the other side. So maybe there's some kind of point over here, and there's some other kind of point over here. And I can find information on this side of the river where I am, that will help me figure out information on the other side of the river. So when you're reading the word problems, you know, it is a lot of text in these problems, but usually they end up with the thing you're trying to find is hard to find, and you're given information that's easy to work with. Okay, and so you can imagine how if I knew something, if I knew, let's say, an angle of elevation to here, and maybe I knew something about the distance from here to here, and maybe I knew some other kind of angle or piece of information, you know, anywhere. It could be anywhere. It could be like this, could be like this, any kind of sort of diagram. Fill in your information and you'll be able to find the missing side. The thing to know is that when you're drawing 3D triangles, anything that is standing high, so let's see, maybe I'll put the CN tower here. Anything that is standing tall is always perpendicular to the ground. So see this CN tower here? Perpendicular to the ground. It'll never be given, but you can assume that because buildings and trees and people and heights in general are always perpendicular to the ground, right? We don't, if I ask you how tall you are, you would stand like this to measure it. You wouldn't stand like this to measure it, right? So you're always perpendicular to the ground. So in your 3D diagram, your thing that's your structure that's perpendicular to the ground, you will show it perpendicular using that 90-degree symbol, but it will look like slanted because you have to imagine that this triangle is standing up and this one down here is on the ground. Okay, in our Romeo and Juliet example, I made this model. Okay, and I purposely left the text, this is a piece of scrap paper, but I left the text showing on the bottom so you could see this was the triangle that was on the ground. These are the triangles that are standing up, and I can make this a right angle, and I can make this a right angle because the building, Juliet's house, is perpendicular to the ground. And down here, for the triangle on the ground, I can't make any assumptions unless the question says. So I can't assume this is 90 degrees. In the question of Romeo and Juliet, it happened to be 90 degrees, but you can't assume that. But anything standing, you can assume to be 90 degrees. Okay, let me show you a quick textbook question. So this is an example on page 264. All right, in this example, they're telling you about these towns, their distances apart, there's a hot air balloon flying up high, they're giving you all this information, and then they're asking you what is the angle of elevation of the balloon. So if this is the balloon up at the top of this part up here and it's flying high, what is the angle of elevation? So that's this angle up in here. So the angle JDJ. So this angle over here, they're asking you what that is. So we figure out that angle until we get more information on the ground. So we'll use the information on the ground to help us with the information on the part that's above the ground. Okay, and for me, it always helps if I have trouble with picturing what's going on. I make a model. So just like I made the model of the Romeo and Juliet, this is just a paper airplane. I know how to make this because that looks like a paper airplane to me. So I made a paper airplane. I had to cut the end off so that it looks like a straight line. And that's all it looks like. So I can see that there's one triangle that's standing up, and that's going to be a right angle triangle. Okay, because that height is always measured perpendicular to the ground. So this is a right angle triangle standing up, but I can make no assumptions about the triangle on the ground. So if making a model helps you, you can always do that, and then you can picture it. Now, the nice thing about this question is that they give you the diagram, because look at all this text, right? But they give you the diagram, so you can manage. But there are questions in this chapter where they don't give you, right? Like let's look at question 4. Okay, question 4 is all this information about trees and all kinds of stuff there, but there's no diagram given. This one's got a pyramid, diagrams given. This one's got a box of diagrams given. This one's not. Okay, so it's a matter of reading very, very carefully, drawing the correct diagram, labeling all the sides, and if you need to, you can make a model. All right, so good luck with that, and thanks for watching.